All right. So where did you want to start with? What page?
Maybe we can start in the rocket science. Yeah, because
What
it's
page?
28. It's yesterday class.
Yeah. Okay. All right. So what one do you want to do now?
Yeah. The second one.
Number 2.
Yeah. The second one. I know the speed, the u, and the v is 0.
Yeah.
Yeah, and just this is my question. I will show it.
Just a sec. Where's my pen? I need to write. Do you see my pen?
No. Yeah, I have one.
No, special pen.
Oh, yeah, it is. Yeah.
Okay. Right, go ahead.
Yeah. This is the cat, and it's 5
5
meters.
meters.
Yeah. We need the speed from here or here.
What do you think?
The cat speed in here in the beginning is 0.
Yes.
And here is this.
Yeah.
Yeah. And which is our need? Is this or this?
This speed you need.
Yeah.
Here.
Yeah. Here.
What's this? 0.5?
No, it's 5.
5.
5. Oh, sorry. It's not.
Yeah, because that's not T.
Yeah.
Yeah, but anyways, you get the V.
Yeah.
You get the V. You need the V.
Yeah. We in this point.
Yeah.
Oh, that's alright. I don't know which speed is I need to slow this question. So
Yeah. Well, just to be clear, this is what happens. Okay.
Yeah.
So here's the cat.
Cat. Yeah.
Cat.
Yeah.
The cat. Here's the cat.
Yeah.
It hits the ground.
Yeah.
And then it bends its legs.
Yeah.
And this time here is 0.25 seconds. Yeah. And there's going to be a V here and a 0 here.
Yeah.
So the delta P would be 0 minus. Yeah. And then if you divide by delta T.
T is 0.25.
Yeah.
Yeah.
This is the idea.
Yeah. And the third one.
The teacher.
Yeah, the teacher. I think the one day's force is the teachers. This is the teachers, and he walk in this way, and the one day's force is there, and the force is 21 and 0. This is the one day's force. Yeah, and this is and the Earth give the force. Well, what's the name? I forget the.
Which name?
Yeah.
The weight.
Yeah, the weight's name. The weight's name.
Weight.
Yeah.
Reaction.
Yeah. Reaction.
And then the wind.
Yeah. The reactions force and the weight force is balanced.
Yeah.
Just the wind's force is.
Yeah. Okay.
Yeah. But it's different. From,
is it?
Yeah.
Let's calculate.
Yeah.
So, how fast is he walking?
1 meter per second.
1 meter per second,
Yeah.
and the wind is blowing at
20 meters per second.
20 meters per second.
Yeah.
Yeah. Okay. this is equal to this picture.
Yeah, 21 meters per second.
Yeah. So the force equals delta P over delta T, which is delta P, which is mv, which is rho v v, which I think I said this is 1, did I? No, I said 1.225. So 1.225 times 21 times, now the volume is 1.82, 0.5 and 21.
Oh, I lost the 21.
You lost this one?
I lost the 21.
Yeah.
I will
calculate, okay.
Calculate for that. Oh, I lost the 21.
Number 3. What did you get?
Maybe I had some mistakes in the calculator.
Are you typing this in?
Yes. Oh, it's different.
You see?
What? What's wrong with this calculator? I attempted this.
Let me see.
It's the first one 1.225, but in this calculator is 2. I don't know why.
2. Something's not right. Hang on. Let me open up my calculator.
It's not so good. The test calls calculator. It's right.
It's right?
It's right. It's 491.6.
Okay.
In my first to do these questions, I think I forget. I forget this. I just showed them. This is the wrong answers.
I understand. Very good. Okay.
Yeah, and the fourth question is too long. I can't understand what this means.
You can't understand it?
Maybe I think is this is a rocket and the gas gives a force is to push this, and the speed is 3,124, and I cannot understand this. This is too long.
Okay, let me help you. The Saturn V rocket, during stage 1 of its flight, reduces its mass from 2.3 million kilograms down to 0.48 million kilograms, because the gas comes out. So what we should do to get the mass per second, it's 2.3 minus 0.48 times 10 to the 6 all over, and this takes 2 minutes.
2 minutes. Oh yeah, it's 2 minutes.
162 seconds.
It's
Okay, so here's the thing. You know this, right?
Yeah.
You also know this 3124. Okay, so you can know this because it's that multiply.
I'm way.
Yeah. MV. Yeah. Do you know the weight?
Weight. Is this?
Well, this is the problem.
Yeah.
The weight changes.
Yeah.
The weight at the beginning is more.
More, and
Yeah.
When he flies, the
It's
gas is less. Yeah.
So what we'll do,
delta weight is.
Well, I would say, yes, but what I would do is I'd say the weight is roughly equal to the weight at the start plus at the end over 2.
Yeah.
Roughly.
Yeah.
So what you can say is the total force
Total
equals T minus, this.
This one.
And that's equal to MA.
MA.
But again, the M would be
the
average. A.
Yeah.
So I think I asked you what's the A, is it?
A.
Yeah, what's the acceleration? See here?
3,000.
What is approximately the acceleration of the rocket? Yeah, so that's me asking what the A is.
Yeah.
So the A will equal mv minus a half, W0 plus W1, over a half M0 plus M1. And you know this, you know this, you can know this, you can know this, you know this, you know this, so you can get the A.
Oh.
Yeah.
The M01 and what?
M0 is this one, and this is M1.
Oh, yeah. Oh.
Okay?
Yeah, it's okay, it's okay, it's okay.
It's not too bad.
Yeah.
It's not too bad.
Because I can't in the beginning I cannot understand this this sentence give me the I think
Gives you the what?
like I can't catch this means. I can't catch this raw means, so
You didn't know what the 2.3 and 0.48 what they mean.
Yeah.
Yeah.
That's okay.
It's okay.
It's
Okay.
okay.
Good. Okay, what else now?
I think it's all. Yeah, it's all.
Yeah.
Yeah.
Number 5. Did you try number 5?
Number 5 is AB I tried, and the next I don't. I don't look them. Yeah.
Okay, fine. What else do you want to do now for the tutorial?
Maybe the Newton's three laws. Yeah. I think I forgot a lot of things about that. Yeah.
Okay, which question do you want to do?
Maybe is the fourth.
Number 4.
Number 4. If I know how to do these questions, I think the others I will.
Yeah. Let's have a look at number 4. A block of 5 kilograms slides down the plane as shown at an angle of 30. Okay, so this is the picture.
Yeah.
You have this here, and that's 30.
30. Yeah. The other.
And this, this is 5 kilograms. What's this called? Don't look. What's this called? This part? This one's called block. And this piece is called a wedge. Block and wedge, okay? The friction, okay, so there's a few forces here.
Yeah.
So there's this force which is mg.
Yeah.
And I show you in the picture, you can write it here and here.
Yeah.
This is mg cos 30.
Yeah.
And this one here,
Sine
30.
Yeah.
There's also friction and reaction.
Yeah.
And I tell you that the friction, in the picture, see?
Oh, yeah.
And I say in the question, the friction force is 1/4 the reaction force.
Oh, yeah. Okay.
So what we can do we can look at the picture, you know, like this.
Yeah, I know.
So it's going to move to the left.
Yeah.
And we want to know what is this acceleration.
Oh.
Now, these are balanced.
Yeah.
So you can see that R must equal mg cos 30. Oh, and we know the g is 5.
G is 5?
Sorry, the m is 5.
Yeah, yeah, yeah.
So that's 5 times 9.81.
9.81.
Yeah, cos 30.
Yeah.
Yeah. Wait. Because I don't care about the or, I care about this.
Yeah.
So what I'll do is a quarter or
Quarter R.
is a quarter of that. Okay, now what do we get?
Yeah.
So we can calculate that. Let's see. Actually, I've got a calculator. 5 times 9.81 times cos 30 divided by 4. 10.62. Yeah. That's 10.62.
Yeah.
Okay. Now, the next thing we need to calculate is this, that mg. So that's 5 times 9.81 times sine 30.
Is 24.523.
So that's that, and that's that.
Yeah, and minus.
Minus.
Yeah.
So the force left is 24.53 minus 10.62. And that should equal 5a.
5a. Yeah.
So
that's right.
if I divide this by 5, I have the a.
Yeah. It's 2.781.
Which is the answer.
781. Yeah. The answer
What's the
is
answer?
yeah. The fourth answer.
Okay.
Yeah.
Not so bad.
Not so
bad. What else do you want to see?
I remembered. Is my first class the ball? There is a ball, and he drop into the oil. Oils. This questions maybe is fourth questions.
Okay, number 4.
Yeah, number 4.
Okay, let's have a look.
Yeah.
So we have our oil.
Yeah, oil.
Okay, and this is 0.1 kilograms.
Yeah.
And this is 30 centimeters.
Yeah.
And the ball takes twice as long to fall compared to no oil.
Yeah.
So if there was no oil, let's calculate the time for no oil.
Oil.
So U 0, V don't know.
We don't know. A is yeah.
Right, so what will give us the T quickly? S equals UT half A T squared.
Yeah.
So T is square root 0.3 over 4.905.
Yeah.
Okay, let's see what that is. Square root 0.3 over 4.905. 0.247.
2.7. Oh,
Yeah.
yeah. Oh, stupid calculator.
Yeah.
Yeah.
Now, for this story here, they said the time is twice as long. So I multiplied by 2, and this is the time here. 0.495.
Yeah.
The U is 0 still.
Yeah.
The V we don't know, the A we don't know, and the S we do know.
Yeah.
So I should get the A. S equals UT plus a half A T squared.
Yeah.
So that's minus 0.6 over, yeah. So I have this on the calculator. I'll just put it over answer squared. So minus 2.453. Well, A is minus 2.4525. About roughly. Now, what am I asking you for? What is the force? So we know that F equals the weight minus the drag, average, because it changes.
Yeah.
So that means mg minus d equals ma. So that will just be 0.24. Yeah, 24525.
Yeah.
So the d. Now hang on, I have to be careful with my signs. Hang on. This is going down. So I'm saying down is positive at the moment.
Yeah.
Right minus that. That's, yeah, okay. So d is 0.981 minus 0.2453.
Yeah.
Whatever. Yeah, that looks about right. 0.736.
Yeah.
Yeah.
Yeah, that's all right. Oh, maybe we can continue.
Yeah, that's the last question.
Yeah.
Yeah. Have you watched more videos?
No.
You know, the videos you missed.
Yeah.
You need for your English.
Yeah. Maybe tonight I will continue watch the videos because
Yeah, what was the last video you watched?
it's science and cosine.
This one, maybe?
Sine, cosine, yeah.
Or maybe this one?
I think it's this one. This one.
No, there's no sine or cosine in that. It must be this one.
This
Resolve
one.
in vectors. So you
Oh.
you have to watch this, or you did watch it?
In the beginning. Maybe it is in the beginning. Yeah.
Okay.
Yeah.
What lesson did you start when you came here? The
It's-
weight lesson?
Yeah. It's
Okay, so you just...
yeah.
Alright,
Yeah.
so just a couple of videos.
Yeah.
Alright, that's okay. Not so bad. Not so bad. You're nearly there.
Yeah.
Okay, let's see now. Okay, let's continue. Let's close this and continue. Yeah, so this is our last class until next week.
Yeah.
Yeah, and I only have one student. Okay.